And good morning. So you'll notice that I've had a cold. I sound a little stuffy, and I can breathe. I'm not stuffy, but I'm at the tail end of the cold, so I might have a little coughing fit. So if I go into a coughing fit, I'll try to pause it so you don't have to listen to me hack and cough. So anyway, all right, so we're going to go ahead and go on to section 18.2. Now I've already done, we've already worked on the first part of this chapter, which was 18.1. We were just talking about surface area and what total surface area meant. So that was basically taking a three-dimensional object, a book, a house, a car, whatever, and just measuring each of the faces of it to see, you know, like if you're going to wrap a gift, how much wrapping paper you're going to need. So basically figuring out the area of the whole object on the outside. All right, so 18.2, if you'll look, the title of this section is volume. So volume is going to be how much inside space in a three-dimensional object. Now going way back, we've studied perimeter and we've studied area. Now, perimeter was basically figuring the amount of space or the measurement outside an object around to figure out how much fencing you're going to need around your garden, or how much lace you want to sew around the pillow or whatever. Perimeter is just measuring the outside of a shape of an object. Area was figuring out the area inside of a flat object. For instance, how much flooring you're going to need. You're going to figure the area. And remember, we always use square feet, square inches, square whatever, because we measure it in squares. So all these were flat objects. Okay, now when we move into surface area and volume, we're looking not at flat 2D objects. We're looking at three-dimensional physical objects. These are definitely, you will use perimeter and area in real life, but you'll also use surface area and volume as well. So let's look at page 350, section 18.2. I'm sipping on my coffee, trying to keep my coughing from coming back. So if you hear me take a break, I'm just sipping on my coffee. All right, let's look at the top here and let's kind of read through this and figure this out. It's time to explore the new aspect of measuring shapes, which is volume. It's the term that we use to describe the space inside three-dimensional or solid objects. We'll focus our explorations on prisms and cylinders. And there's a picture of one right there, both. We're going to look at how to find the volume or the space inside of both prisms and cylinders. Now remember, prism and cylinder are names that we use to describe specific three-dimensional or solid objects as a whole. So a prism is, it kind of looks like a big tall square. Now the bases are polygons. Remember, a polygon has straight edges and it's a closed object. Remember that. So the bases of a prism would be polygons. Both bases are always the same and parallel. The sides are always parallelograms. So basically when we talk about a prism, we know that we're talking about a something that's going to be parallel. It's going to be a little bit easier to measure. Now a cylinder would be like a can of green beans or something. So the bases of a cylinder are always circles, and both bases are the same and they're parallel. So before we look at finding the volume, we're going to take a look at the units that we use to describe the volume and why we do it this way. So when we do volume, we use cubic units. Now what we use, well, I just said that. I'm fixing to read what I just said. We use what we call a cubic unit to measure volume. Unlike a square unit that has two dimensions, a cubic unit has three dimensions: length, width, and height. So stop right there just for a second. let me go over here to, well, actually, I am on my whiteboard. So if we look at this square, pardon me. So a square is a flat two-dimensional object, and if we have a room and we want to figure out how many square feet of tile we want, then we got to use a square foot, which would be 1 foot on all 4 sides, meaning it would be at 1 square foot. And then we would line them up side by side until the whole room was filled, and then you'd count. Or, you know, you could count down and count across and multiply, and that would give you the area. But in cubic, and these are two-dimensional objects. That's why when we do area, we always say the answer would be, for instance, it might be square feet or square inches. Or remember, we did learn to do this to show that we measured using a two-dimensional square. Okay, so when we measure a surface area, or I'm sorry, volume, we're using cubed. So in other words, rather than using this square to measure, we're using a three-dimensional cube. So it's going to have length, width, and height. So it would be cubed feet. Or it depends on the cube. It could be feet on all the sides. It could be inches on all sides. It could be yards on all sides, whatever. Or another way to say that would be this. Okay, this shows area because we've used a flat two-dimensional object. Okay, or on volume, you use cubic, whatever the unit is, feet, inches, yards, meters, miles, whatever. And so you're going to use a 3 because that shows that we've used a three-dimensional object to measure with. All right, so let's look back at our book. I'm right underneath where it says cubic units. A cubic unit is 1 unit wide by 1 unit long by 1 unit high. And there's you a little tiny picture of a cube. Pardon me. That's why we use the 3. Notice that. It has 3 dimensions to it. It has length, width, and height. Okay, so a volume of 4 cubic units would be able to contain 4 of these 1 by 1 by 1 cubes. There's your picture of one. Now, look where it says finding volume. Consider this box, which is a rectangular prism. This would be like a tissue box, like a big long tissue box. All right, back up at the top of page 351. Notice that it's a rectangle with height. We know how to find the area of the rectangular base. Remember how to find just the area of a rectangle? It's just length times width. The area of the base is length times width, so it'd be 5 times 4, so it'd be 20. So the base of that rectangular prism is going to be 20 square units, whatever the units are. I don't know. It doesn't say what units they are, but it'd be 20 square units. Now, if we multiply that area by the height, which is 3, you'll know the volume. Note that to do this, we'll use cubic units, which are tiny three-dimensional cubes, rather than the two-dimensional squares that we used for area. So look at that square at the top of 351. Notice they use little tiny squares to find just the area. Those are just two-dimensional, just whatever. But then to find the volume, they made them into three-dimensional cubes. So then they take the area of the base, which was 20, 4 times 5, times the height. So it's going to be 60 square units. Whatever it didn't tell us what the units are. Now, when we find volume, we're multiplying 3 times and measuring the number of unit cubes that fit inside the solid object. So I found this picture that might help us. I'm sorry, it's kind of big. Let me get it down just a little bit. So I found this picture online. It kind of gives you a little view of what volume is. So here we have this big cube, okay, and then we have all these cubes down here. Now notice these cubes down here are three-dimensional, okay. They've got length, they've got width, and they've got height, okay, and they're showing you how they lay the base, and then they'd fill it up, and then to figure out how many you would need, all you would have to do is you'd have to multiply 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 by 10. So 100 cubes would fit at the bottom, just at the base, because 10 times 10 is 100. Okay, now to figure out how many little tiny cubes you're going to need to fill up this entire cube itself, you would take 100 and multiply it by how many these are, which I'm guessing that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. No, it would be 9. So 100 times 9 would be 900. So you'd have 900 cubic square, whatever these are. Okay, inches or cubes or yards, whatever they are. Same thing over here, except these are a little bigger. Okay, I just want you to get the idea of what volume means, and that's what it means. Okay, so let's go back to 351, kind of in the middle, underneath that second picture. So assuming the dimensions in the prism above are in inches, you would have 5 inches times 4 inches times 3 inches equals 60 inches times inches, or just 60 cubed inches. In other words, this prism holds 60 cubes that are 1 inch by 1 inch by 1 inch. We thus say it has a volume of 60 cubic inches, which is read 60 inches cubed or 60 cubed inches, or however you want to read it. If, on the other hand, the dimensions of the prism above were in feet, it would have a volume of 60 cubic feet. And you would just change the unit. All right, let's look at the very last paragraph on 351. Notice that we used exponents to abbreviate inches times inches times inches to inches cubed, and feet times feet times feet to cubed feet. Volume is measured by a three-dimensional unit, one with length, width, and height, rather than by a two-dimensional unit, and thus we end up multiplying 3 distances to find it. Okay, so I hope you're understanding this far. I hope I'm not repeating myself for no good reason. I don't want to bore you to death, but I just want to make sure you're understanding the difference between area and volume. Area, just two-dimensional. Volume, three-dimensional, 3D. All right, look at page 352. Okay, so there's a gray box at the top, says it's cubed. While we're looking at cubic units, let's talk about a cube. As we saw in section 13.4, a cube is basically a prism with sides that are all the same size squares. So in a cube, the length, width, and height are all the same. Not surprisingly, a cubic unit is a cube with sides 1 unit long. Whenever it says unit, that means that word could be anything. Feet, inches, miles, meters, kilometers, whatever. Okay? When we first studied exponents, we learned that 2 to the 3rd power is read 2 cubed. You could say 2 cubed or 2 to the 3rd power. You can guess why. The name makes sense, as 2 cubed represents the volume of a cube with sides of 2 units. Okay, so let's look at the formula for volume. Notice that to find the volume, we found the area of the base, then you multiplied that by the height. You can use this process to find the volume of any prism or cylinder. Okay, so underneath this prism, look right there where it says volume of a prism or cylinder. This is, now if you're keeping notes of your formulas, you could write this down. Volume of a prism or cylinder equals area of the base times the height, or V equals base times height. Pardon me. Notice in that second formula there, the B is uppercase, the letter B for base is uppercase, and the H is not. That reminds you to find the area of the base. Okay? All right, so let's talk about these terms for a minute. It says as terms can have different meanings in math. The important thing is to understand the concepts the terms are describing. So previously, you've used the word base to mean the length or the bottom of a parallelogram. Remember when we were finding the area of a parallelogram, it'd be base times height. Okay, but now here, we're using it to describe one of the sides of the prism or cylinder that forms the basis. So the base of this three-dimensional object. Now, look at the top of 353. What about height? Well, we're using height to describe the height or width for which the shape of the base continues. Now, look at the cylinder, and then look at that triangular prism at the very top of 353. Now, the B's stand for base. So on a cylinder, the two circles are always the base. The height is the distance between both bases. Okay, and then look at your triangular prism there. You've got your bases there, which are triangles, and then your height's the distance between the two. Now here's a great big gray box here on the middle of 353. Which side is the base? Notice that in the case of a rectangular prism, we could think of any side as the base, so long as we view the other dimensions as the height. So a cylinder is easy because you know the two circles are the bases. A triangular prism is easy because you know the two triangles are the bases. It's not so easy when you're looking at a rectangular prism because all the sides could be rectangles, are rectangles. So it's showing you here that really it doesn't matter on a rectangular prism which sides you use as the base, as long as you use the two opposite sides as the base and then the other sides as the height. So right here it's showing you, pardon me, it's showing you the same rectangular prism, and it's putting B on the different things that you could use as the base, just so long as you use the other faces as the height. Okay? Now, on the other hand, this is right in the middle of this big gray box. On the other hand, in a triangular prism, we have to view the triangle as the base, or we wouldn't end up being able to calculate the volume using our formula, since the rest of the object wouldn't be the same as our base. So check this out. When you have a triangular prism, always use the triangles as the base. Now remember how you find because you got to find the area of those two faces. So remember how to find the area. Remember, it's half. A triangle is half base times height. So, pardon me. So look underneath, right underneath the two triangular prisms at the very bottom of 353. The volume equals half, because remember it's half, because this is a triangular prism. Half times 2, and then times 4, because 4 is the height. Okay, so it'd be 8. And then it's showing you if it stood up on its side. You're still using the same, sides, and you're using the same bases. But when picking a base, make sure you pick a side that continues uniformly throughout the rest of the object. Just all you really need to remember is if it's a rectangular prism, you can use any of the sides as the bases. But a cylinder and a triangular prism, you're going to use the triangles or the circles. Okay, turn the page. So 354, we've got an example up here, finding the volume of a rectangular prism. Okay, so they've written the formula right below it, V equals B times H. So in this case, our base is a rectangle. So the area equals the length times the width, or 5 inches times 4 inches. So our volume is 5 times 4, which is, or times 15, which is the height. So that equals 300 cubic inches. Okay, notice that since our sides are also rectangles, you could have viewed any of those sides as the bases. You get the same answer no matter what you used. If you said 15 times 5 times 4, 15 times 4 times 5, it didn't matter how you do it, you're going to get the same answer, just because it's a rectangular prism. Okay? Now here we have, on the second example, you've got a triangular prism. So we're going to find the volume of a triangular prism whose base is a right triangle and the dimensions are shown. Volume equals base times height. Always write your formula first. So in this case, our base is a triangle. We need to first find the area of the triangle. So that would be half base times height. When finding the area of the base, ignore the prism and find the area of the triangle, just like you normally would. Note that this triangle has a right angle, so its height will equal the length of one of its sides. Pardon me. So area of the base, which would be half base times height. Fill in your numbers. Half times 3 times 4. You get 6 square feet, because that's just the area. Now, then you take, to find the volume, you take 6 times 5, which is the height, and you get 30 cubic feet. Okay, let's look at the volume of, the example of the cylinder. Okay, the volume of a cylinder whose base has a diameter of 5 feet, and it's 15 feet tall. All right, up at the top of 355, they've written the formula. In this case, our base is a circle, so we need to first find the area of the circle. Remember doing that last week, I think it was. So the area of the base is pi times radius squared. So the area of the base is pi times 2.5 square feet, because 2.5 would be half. That would be the radius, because the diameter is 5. Remember, the radius is half the diameter. Okay, and that equals 19.63 square feet. So the area of the base is 19.63 square feet. Note we found the radius by taking half the diameter, okay, blah, blah, blah. Then you're going to take, to find the volume of that cylinder, you take the area of the base, which is 19.63 square feet, times 15 feet, and you get 294.45 cubic feet. Okay, now, customizing the formula. In other books, you may find the formula for volume customized based on the type of base. For example, you might be familiar with finding the volume of a rectangular prism by multiplying the length times the width times the height. So you might find volume equals length times width times height. Basically, these more specific formulas just replace B, which represents the area of the base, with how to find the area of that specific type of base. So the volume of any prism or cylinder is volume equals base times height. The volume of a rectangular prism, volume equals length times width, which would be the base, times height. The volume of the cylinder would be volume equals pi times r squared, which is the area of the base for a circle, times height. Okay, so that's just showing you that the very first formula, volume equals length times width times height, that's actually how I learned it in school. But what we're learning in this book is just volume equals base times height. So the other two, the rectangular prism and the cylinder, those other two formulas are the same thing. It's just showing you how to figure the base. Okay? All right, so the first formula applies to any prism or cylinder, while the next one applies only to a rectangular prism, and the last one only to a cylinder. The basic principle is that you find the volume by multiplying the area of the base times the height. Okay, so that's the main thing. So you can just write the formula volume equals base times height if you can remember how to figure the base of a rectangular prism and a cylinder. If you don't think you can remember that, then just write, like on a note card or where, if you're taking notes or whatever, volume of a rectangular prism would be volume, or V, equals L times W, which is length times width, and then times height. Or volume of a cylinder, volume equals pi times r squared, which is the area of the base, times height. Okay, I hope I didn't confuse you there. All right, so let's look over, let's see, that's just the keeping perspective. This was a long lesson and we're not quite done yet, so we're not going to do that. Okay, so let's take out our work. There's two work text pages. There's 18.2a and 18.2b. Okay. So On 18.2a, on number 1, it says find the volume. Hint, be sure to list your answers in cubic units. Remember to find the volume first. To find the volume, first find the area of the base, then multiply that by the height. So find the volume of A, the drawer, if it's 10 inches long, 8.5 inches wide, and 2.5 inches thick. All right, let me work through this one with you then. If you know it and I'm just wasting my time with you, just go ahead and turn it off. Otherwise, I'll help you through these, a few of these. I'm just going to kind of pick a few. All right, so in 1A, so the first thing we're going to do is we're going to write our formula. Okay, now this drawer is going to be a rectangular prism. Okay, so let's go ahead and fill in our numbers. So base, remember, for a rectangular prism is going to be length times width. So let's look at our inches up here where it says. So it's 10 inches long, so that's length. 8.5 inches wide, that's width. So it's going to be 10. We want to put this in parentheses. Inches times 8.5 inches, okay, and then it's 2.5 inches thick. Okay, that's going to be your height times 2.5. So volume equals, now it doesn't show you can use a calculator on this part, so we'll have to do this ourselves. So 8.5 times 10, always do what's in parentheses first. Remember how to do that. Now remember, we're just multiplying by 10. So when we multiply, the decimal goes one place to, when we multiply by 10, goes one place to the right, because remember, multiplication makes the number bigger. Rabbits multiply, so they get bigger. So it'd be 85. This would be 85. 5 inches times 2.5 inches. Okay, so then your last answer, you're going to, I'm not going to do it myself, but you would take 85 times 2.5, get your answer, and that would be your answer. Make sure that your answer is cubic inches. Okay? All right, that's what you're going to do there. All right, let's look over, before you finish this one, let us see if there's another one I need to help you with. Look on the back of 18.2a, the total surface area. Okay, you can use a calculator on this one. It says draw out the problems if you need to. Okay, now this, like I said, this is surface area. So this is going to be what we learned in section 18.1. So you might want to go back and look for that. So basically what you're going to do is you're going to find the area on 2A and 2B. You're going to go back and use those items on the other problems on the front part of the page, and you're going to find the area of each of the faces. Remember how to do that? Remember, area is just length times width. Okay, and you're going to find the area of those, of each of those. So go back and look at 18.1 at how to do surface area. You know how to do the area of an object, just length times width or base times height or whatever it is. So on 2A and 2B, you're just going to break up these 3D objects into all of these faces. So it's going to be kind of long problems. Okay, the rest of those you should be able to do. On 18.2b, on 1A and 1B, see if you can get a measuring tape or ruler or something and go around the house and see if you can find. Now, if you don't have something, just mark it out and write something like maybe box of rice or box of cereal or something that could replace these. And then just find the volume of these, okay? And then on 18.2 B, number 2, A, B, C, and D, and E, These are just, and you can use your calculator. Let's see what you can do on those without me helping you on these, because these are just going over everything we've learned. And on the back page of 18.2b, on number 3, these are volume. Okay, on 18.2, worksheet 18.2b, on the back, number 3, this is a challenge. So I'm going to leave it optional. You don't have to do that. If you do it and you do well on it, then I'll give you bonus points on that. Okay? I don't think I'm going to grade either one of these pages. But if you do the back of 18.2b and you do it well, then I'll give you bonus points. Okay? All right. Long lesson. I apologize. Let me know if you need any help at all. I'll be happy to help you with anything.